Hello dear students, welcome to EPG Pathshala. I am Dr. DC Saxena, Professor and Head, Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am here to present the paper Technology of Meat, Poultry, Fish and Seafood Products, and in the present module you will be given the knowledge of minced fish, surimi, retort process fish curry as a value-added fish and seafood products by my co-author Mr. Narendra Kumar Chandla.
Hello students, welcome to EPG Pathshala. I am Narendra Kumar Chandla from Sant Longowal Institute of Engineering and Technology. Today I am going to talk about module 33 of paper number 8, that is Technology of Meat, Poultry, Fish and Seafood. In this module, we will be discussing about value-added fish and seafood products. For example, minced fish, surimi, retort processed fish, curry, fish protein isolates and concentrates and fish gelatin. As far as international trade is concerned, in international trade in the fish and fishery products have grown substantially over the last decades. Today, more than 30% of the fish caught for the direct human consumption, which enters in the international trade market. Developing countries account for about approximately 50% of the global fish exports. However, despite the availability of the technology, many projects in the evaluating in the seafood resulted in good export. Careful consideration was not given to the various facets of their feasibility, including quality assurance, marketing, distribution, transportation, and trade barriers before embarking on the value adding of the fish process. Fish after harvest itself is not inherently stable. Therefore, value-added products like fish curry, fish protein isolates, and concentrates and gelatin can be made out of it. With due course of time, frozen storage was possible, and it was found that gel forming capacity of a frozen surimi was poor on time. Thereby, discovery of the cryoprotectants helps in the production of the surimi, and its gelling ability remained for the longer time, even after on the longer freezing. The thermally sterile processed fish curry preparation have been discussed, which need not to be rehydrated or cooked and can be consumed straight from the pouch with or without pre-warming, depending upon the requirement of the users and the weather conditions. Therefore, to get the variable taste from the seafood, new value-added seafood products need to be developed throughout the globe. So, this perishable product as a fish will be consumed into or will be converted into number of products so that these products may be consumed by customers across the globe, across the world. In this module, we will talk about minced fish, utilization of minced fish, surimi as a fish product, utilization of the surimi, surimi processing operations, surimi quality, retort processed fish, fish curry, fish protein isolate, fish protein concentrate, fish protein hydrolysis, and fish gelatin. Value-added fish and seafood products. As we know, international trade in fish and fishery products have grown substantially over the last decades. Today, more than 30% of the fish caught for direct human consumption, which enters international market. Developing countries like India account for approximately 50% of the global fish exports. However, despite the availability of technology, many projects in value adding in seafood resulted in good market and export. Careful consideration was not given to the various facets of their feasibility, including quality assurance, marketing, distribution, and trade barriers before embarking on value-adding fish process. Therefore, to get variable taste from seafood, new value-added seafood products are developed throughout the globe. Historically, the Japanese produced surimi, which is well known, is converted into kamaboko product on routine basis. This was required because in early days there was no frozen storage, and surimi itself is not inherently stable. That means it required something as an agent for the preservation. With due course of time, frozen storage was possible, and it was found that gel forming capacity of the frozen surimi was poor on thawing. The discovery of the cryoprotectants as an agent help in production of surimi, which will have gelling ability and could sustain for longer time even after on longer freezing. Surimi and fish mince. Frozen storage of surimi and fish mince. The behavior of actin and myosin in the frozen storage is premier important, as both surimi and minces are stored in this way prior to the final processing. The major problem is denaturation of actin and myosin, which reduces their water binding capacity or water binding properties in subsequent processing. Then is minced fish. Minced fish is a comminute flesh produced by separation from skin and bones. In this processing, separation is done by mechanical means, whereby the skin and bone is removed from the flesh. Bone separators working on different principles are available commercially, but the separator most widely used for fish is of comparatively simple in design. Some people do not like fatty fish such as herring and mackerel because of the large numbers of small bones remaining in the fillets. Mince made from these fishes is relatively free from bones and might therefore be more widely acceptable. Flesh from underexploited species such as blue whiting that are difficult to fillet efficiently and can readily be removed in a bone separator. Mincing can increase the risk of oxidation due to membrane disruption, contact with metals, and air, as mincing also increases the area of exposure of the tissues, or especially the fat which are adhering inside the tissues, and makes it susceptible for the oxidation and substantially for the development of the rancidity in the final product. Minced fish is more easily denatured during freezing. Therefore, fish used for making mince has to be of very high quality in the form of a raw material, and processing has to be completed quickly with emphasis on hygiene and low temperature during storage. Utilization of fish mince. Small amounts are used in the fish cakes and in less expensive grades of fish fingers, and some are used to fill voids in the frozen laminated blocks of fillets from which portions and fingers are cut. Mincing offers an opportunity to exercise greater control over flavor, appearance, and other keeping qualities by the incorporation of additives. As we know, additives, they do have a special group which will have an action of preservation. Rancidity in fatty fish, for example, can be controlled more easily in minced flesh by intimate mixing with permitted antioxidants, or minces of different fat content can be mixed together to give a more desirable result, but also very valuable products. When fish flesh is minced, the texture, flavor, and sometimes the color are changed. Hence, minced fish and the products derived from it have at present only limited outlets. Small amounts are used in fish cakes and in less expensive grades of fish. However, the mince is difficult raw material due to its high diversity. Therefore, it is difficult to use mince for the standardized products such as ready-to-eat products. The market for the mince is small compared with the amount of the mince that could be made available from all suitable species. Fish mince can also be successfully used directly in the various food formulations and in physically or chemically altered form or modified form to produce an array of nutritional and especially the functional products. Recently, new applications for mince have emerged as a material in protein products for fillet injection. Fish mince products, frozen blocks of mince can be used to replace fillet blocks in fish sticks and portion. Attempts are made to use mince as an extender for extruded crab and shrimp products, which gave fair results, but products prepared were inferior to the surimi based products. Fish mince can also form the base of the chowder or fish soup. In case of surimi and fish product, the essential difference between surimi and fish mince is the latter. There is no separation of the proteins and lipids. Hence, the component which lead the instability in the form of enzymes, pigments, and lipids are present. The given texture and flavor changes on storage. The fish mince products are closer in nature to fillets than are surimi products. The vast increase in the production of the surimi based products notwithstand the quality of the products. The modern process is highly equipped, produces good quality and sold a good price at premium market across the board. Suraimi process operation. Here in this slide, we will talk about the production process of the surimi. The production of the surimi follows several basic steps, while the degree of mechanization depends on the sophistication and the scale of the production. That means whether the surimi is going to produce on a small scale or in a medium scale or in a large scale. So, the process depends upon the scale of production. The general processing steps include treatment of the raw material in terms of chilling, heading or gutting the fish, or the bone separation, leaching, dewatering, mixing with additives like cryoprotective agents, and then subsequent freezing before thawing is done. First step is raw material. The raw material quality control is on paramount importance to achieve the ultimate quality of the finished product. Fresh fish are preferred as they produce less blood and gut resides in the tissues and experience less autolysis of muscle protein, giving a better gel. A uniform size of fish with good flesh is important for consistent yields from deboning machines and overall recovery of the mince. The second process next to the raw material is fish preparation. As we have done the quality control operations in the raw materials, now we will talk about the preparation of the fish. The transformation of raw fish into fish mince, which is an intermediate raw material for the Suraimi process, also plays an important role in quality of the fish or the quality of the fish Suraimi. Once the fish is cut open, the opportunity for biochemical interactions and bacterial contamination results in loss of the muscle protein or even dewatering of the muscles. Next operation for the production of the Suraimi is washing. The cycle of washing, rinsing of fish mince with water is central process in the Suraimi production. Washing facilitates the removal of the water soluble muscle like protein, enzymes, pigments, lipids, and heme, causing oxidation, leading to protein denaturation. The water temperature is usually in a range of 5 to 10 degrees centigrade, which is applied to prevent the protein denaturation. Hard water affects the texture, color, and water with a high quality as a high pH is required for the washing purposes. Next to the washing is refining and straining. This operation can be performed by pre or post dehydration. The purpose of refining is to remove the bones, skin, and this is further applied by the removal of dark muscle if it is objectionable. Next to the refining and straining is our dehydration. In this case, extruders were used where extent of water removal depending upon the resident time and on the pressure exerted. The final moisture content of the minces varies from 80 to 85% on wet basis. Now we will talk about our next operation, that is the addition of cryoprotectants. The cryoprotectants used are sucrose, sorbitol, and polyphosphates in the various combinations. Their mode of action helps in retaining the gel forming capacity and to sustain the quality throughout the chain up to the consumers. The addition of these helps in keeping the Suraimi originally even after longer storage period. Utilization of Suraimi. The most important properties of Suraimi are its gelling ability as well as being a colorless and odorless stable protein mass. These features enable the application of the Suraimi in the various products. For example, crab sticks. Suraimi is useful ingredient for producing various kinds of processed foods. It imitates the texture and the taste of the more expensive product such as lobster tail using a relatively low cost material. Suraimi is an inexpensive source of protein. In Asian culture, suraimi is eaten as a food in its own right or seldom used to imitate other foods. Freeze-dried suraimi is a commercial product which is sold in Japan. As in the last slide, we have talked about the utilization of the suraimi. So we will like to add few more points over here. Washing fish mince with water, mixing with sugar and phosphate, followed by freezing to produce suraimi, increases the stability of the fish protein. In the Western countries, suraimi products are used imitation seafood products such as crab, abalone, shrimp, calamari, and scallop. Several companies produce suraimi sauces, luncheon meats, hams, and burgers. A patent was issued for the process of making even higher quality protein from fish, such as in the making of imitation steak from surimi. Surimi is also used to make kosher imitation shrimp and crab meat using only kosher fish such as pollock. Freeze-dried surimi is a commercial product in Japan-like countries. It is used as binder, dispersing agent, and as an emulsifier in restructuring the fish products or other meat products like beef, pork, and chicken meat. It is also used for the formulation of the exotic dishes. As we have talked about surimi production, now we will be talking about the quality of the surimi. Surimi quality is primarily decided by the quality of the intermediate products, which are known as kamaboko in Japan. The Japanese set the strict standards for thawed surimi based on color, flavor, and gel formation, which is due to the actin and myosin properties. Other tests performed are chemical, like pH and moisture, they affects the quality. And in case of physical, drip loss and viscosity of the surimi affects the overall quality of the surimi. The gel quality should withstand and prove the quality of the raw material, washing cycles in the concentrating of actin and myosin, etc. As far as the raw surimi is concerned, raw surimi is tested for moisture, pH, presence of the impurities like dark skin, bones, whiteness, and physical attributes, or like drip loss and the viscosity. Retort processed fish. Retorting produces a self-stable food product that does not require refrigeration. Therefore, retorting is required for the processing of the fish. The thermally sterile processed fish curry do not require rehydration or cooking and can be consumed straight from pouch with or without pre-warming, depending upon the requirements of the users and the weather conditions. These foods meet the specific needs of the convenience, nutritional adequacy, self-stability, storage, distribution to the centers, and have become very popular. These are processed at 121 degrees centigrade or at the elevated temperatures for complete destruction of the microorganisms and their spores. The retorting process involves sealing a low acid fish product in a hermetically sealed container and applying sufficient heat to render the product commercially sterile. Commercial sterile is defined as the destruction of the all viable microorganism which are concerning with the public health. Retort typically utilize pressurized steam as a heat source, though the actual heating medium may change. Due to their flexible nature and their potential for the expansion during processing, retort pouches are placed in metal or plastic racks to maintain pouch thickness during the retorting process. Fish curry. Here we will talk about the preparation of the fish curry. First, cutting of the fish into medium-sized pieces is done. Then heat the ghee or the fat or lipid in a frying pan and fry the fish pieces gently for 5 minutes. Then drain the fish on absorbent kitchen paper and set aside. The next operation is chop one onion finely and grind the other one. Chopped onion in the pan was taken and fried until golden color. Next operation is addition of the spices and cooking them for 10 seconds while stirring. Now add the grinded onion, garlic, ginger and tomato puree. Next operation is addition of the water and salt. Bring the mixture to boil and add fried fish pieces. Then next operation is retorting. In this, retort the mix in a flexi pouch at 121 degrees centigrade for 15 minutes to inactivate Clostridium botulinum and its spores. Fish protein isolate. Here we will talk about the isolation process of the fish protein. Fish protein isolate is a fish protein which has been purified to the protein content of at least 90% of the dry material and even further purified to have a fish protein mass. The term fish protein isolate, which may be called as FPI, is however in general used for pure fish muscular proteins which have been produced by a shift in the pH. This method is thought to be more efficient for complex raw materials such as whole fish and rest of the raw material than the Suraimi process. The adjustment in the pH results in the isoelectric point of the protein so that there may be the separation of the protein out of the fish. The overall process concept is simple and includes the steps like solubilization of the protein as by adjusting the pH by alkali or with the acid, separation and then precipitation. As we talked about, precipitation may be due to the isoelectrical pH attained by the particular protein. Then the material after adjusting subject to the homogenization at low temperatures. Solids such as bones, scales, fat and the cellular lipid membranes are then removed by the application of centrifugation. Then the process has given excellent results when given a treatment in cold water and even on the warm water for some of the species. Protein concentrate isolation from the fish. Fish protein concentrate is a tasteless, odorless and bland color product. A special fish protein concentrate, namely fish protein concentrate A, had a minimum of 67.5% protein and maximum of 0.75% of fat. The United States Bureau of Commercial Fisheries has promoted the production of the fish protein concentrate for the human consumption. Moreover, an enzymatic method to isolate the fish protein have been developed. In this method, we had a blend in the flavor and has good functional properties which is producing by the use of the enzymes like papain, pancreatine, bromelain and ficin. The process involves hydrolyzing the fish protein, reacting this with the phosphate. Second step is the protein phosphate complex is precipitated at a pH of 2.5 to 3.5 and the precipitate is centrifuged, washed and subsequently extracted with a polar solvent to remove the lipids. Next process is the neutralization with the base and 10 to 20% carbohydrates are added. It is then dried by the process of spray drying or the drum drying. Fish protein hydrolysis. Fish protein can be broken into small units by hydrolysis to yield peptones, partially hydrolyzed, water soluble and non-coagulable, and finally into albumin and amino acids. The first step in the protein hydrolysis is grinding the fish with water and then hydrolyzing this with peptic or tryptic enzymes or with other acids or base at low temperature and at low pressure. Separation is done and the removal of the salt acid was done. The hydrolyzed protein is then concentrated by spray drying or the drum drying or by any other technique. The final product may have a lipids in a range of 5 to 10% on dry basis. Fish gelatin. Gelatin is derived from collagen, which is principal constituent of the connective tissues and bones. This is also reflected by worldwide annual production of the gelatin, which is 3,26,000 tons, with pig skin, bovine hides and gelatin accounting for 46%, 29.4% and 23.1% respectively. It is well known that cold water fish gelatin exhibit good emulsifying and film forming properties. The main application area is therefore embedding of the oil-based vitamins. Suppliers of the vitamins use cold water fish gelatin for the micro encapsulation of the oil-soluble substances and other vitamins which are soluble like A, D, E and K or the carotenoids. Cold water fish gelatin is also having its use in pharmaceuticals and the nutraceuticals or even in the cosmetics and in other food applications. So here we summarize what we have learned in this minced fish, suraimi, fish protein isolate, gelatin and retort processed fish curry have been studied as regard to that as a product of the fish. Minced fish is a comminuted flesh produced by separation from the skin and bones. Separation is a mechanical process whereby the skin and bone is removed from the flesh. The essential difference between suraimi and fish mince is the latter there is no separation of proteins and lipids. The thermal sterile processed fish curry do not require rehydration or cooking and can be consumed straight from the pouch with or without pre-warming depending upon the requirement of the users and other weather conditions. These foods meet the specific needs of convenience, nutritional adequacy and shelf-life. The retorting process involves sealing a low-acid food, in this case a fish, in a hermetically sealed container and applying sufficient heat to render the product commercially sterile according to the regulations set by FDA and USDA. So students, let us now summarize what we have learned in this module. In this module, we have learned about the fish products, especially the suraimi, minced fish. We have discussed their production techniques in detail along with the quality of the suraimi and the minced fish. We have also discussed the process of fish retorting and fish protein isolates and the concentrates. We have also have an idea of fish hydrolysis and isolation of gelatin as an intermediate product suitable for number of food formulations. The production of surimi follows several basic steps, while the degree of mechanization depends on the sophistication and the scale of production of the surimi. Even this production may be differ for the different companies and at the different locations. The general processing steps include treatment of the raw material, that may be the chilling, hadding and gutting of the fish. Another is meat bone separation, leaching, dewatering, mixing with the cryoprotecting agents as to have more of the gelling properties, and freezing. The United States Bureau of Commercial Fisheries have promoted the production of fish protein concentrate for the human consumption. As we know, protein is the major nutrients which needs to the human beings for the growth of the tissues and maintenance of the tissues during diseases or aging. The thermally sterile processed fish curry do not require dehydration or cooking and can be consumed straight from the pouch with or without pre-warming. Another about the value-added fish and seafood products, that we need to have a number of products like surimi which may be taken as a staple food across the world so as to have the best utilization of the seafood products. Thank you.
Now you are well versed with the value-added fish and seafood products like minced fish, surimi, retort process, fish curry, which has been very well explained by my co-author. Now in the next module, you will be knowing about different byproducts and its utilization from meat and poultry industry. Thank you.